So here we have a distance time graph which shows information about part of a car journey. So on the y-axis here we have the distance travelled by this car, and then on the x-axis we have the time in seconds. And for us to use this graph to estimate the speed of the car at the time 5 seconds. So if we have the distance on the y-axis and this time on the x-axis, I can already see this relationship between distance and time and how it might give me speed. Now if I have a look at the equation, speed is going to be equal to distance over time. And now we have distance and time, distance on the y-axis, time on the x-axis. And if I have a look at what the gradient of a graph is, so m, that's going to be equal to the change in y divided by the change in x. Now in this case, the y-axis has distance on, so distance and the change in y, over the change in the x-axis, which is time. So in order to get the speed at a certain given time, the instantaneous speed, I need to find the gradient of the graph at this point. And in order to do this, I can use drawing a tangent and then find the gradient of this tangent. So if I need to find an estimate for the speed of the car at 5 seconds, I can go to 5 seconds on the x-axis and then trace upwards until I meet the graph at this point here. So then at this point here, I now need to draw in a tangent. So a tangent is a line that's going to be at 90 degrees to this point of the curve. So if I sketch in a line here that touches this point on the curve at 90 degrees, I've now drawn in a tangent. And in order to find the speed of the car at this time, I need to find the gradient of this tangent. So I need to find the change in y over the change in x. So I can take values, for example, if I go from this point here and draw a triangle downwards to the bottom of my point here. So this is going to be the change in y, and then this value here is the change in x. So the gradient is going to be equal to the speed, which is the change in y. So we've gone from this value of 68 here for the change in y, down to a value here of 4. So 68 minus 4 is the change in y, and that's going to be over the change in x, which we have here is at this point 7.8. And then we're subtracting this value here, so 3.2. So I have 64 divided by 7.8 minus 3.2. So that gives me 4.6, and I have 64 divided by 4.6, and that gives me an answer of 13.9. So the final answer here of 13.9 meters per second is going to gain me all of the marks for this question. The first mark would be for drawing the tangent to the curve at the point where time is 5. And then there's going to be another mark for the process of finding a gradient of this tangent. And then the final mark is for an answer in the range of 11 to 19 meters per second, just depending on how exactly the tangent's been drawn in, as this may cause a slight difference in the gradient.